So this is going to be 6.7 polygons in a coordinate plane. So here are the ones that we've learned so far. We have a parallelogram where it literally says parallel in it. So we have two sides, two opposite sides being parallel. A rhombus is equilateral. So all the sides are equal. Rectangle is for angles being congruent, and they're always 90 degrees. A square is regular, so all the sides are congruent and all of the angles are also congruent. A kite kind of looks like this, where we have no parallel sides and congruent consecutive sides. Okay, so these sides would be congruent and these sides would be congruent. A trapezoid will have a parallel set here, and then an isosceles trapezoid will have it being parallel and also two congruent sides. Okay, we're going to be using the distance formula, and then we'd be finding the distance between 2 points, so we'll be using points like x1, y1, and x2, y2. And our slope formula, we're just using a point x1, y1 again, and x2, y2. Okay, we'll be using slope to figure out if things are parallel, so that means the slope is the same. Perpendicular, remember, is the slope. Oops. The slope is the opposite reciprocal of each other. Okay, so determine whether triangle XYZ is scalene, isosceles, or equilateral. So scalene means all the sides are different. Isosceles means two sides are the same, and equilateral means all the sides are the same. Okay, so we need to figure out if the sides are all the same size, if only two of them are the same, or if none of them are the same. So we're going to have to use this distance formula right here to check the sides. So first, you're going to get your points. So we have x, y, and z. So I found my points. I got x being at 4, 2, y being at 2, negative 2, and z being at negative 2, 0. So now I need to use the distance formula. So what we found back here for my points, so that I can find the distance to see how long those lengths are to see which type of triangle it is. So let's do xy first. So xy is going to be 4, 2, and 2, negative 2. So let's say this is x1, y1, x2, y2. We're going to do x2 minus x1 squared plus y2 minus y1 squared. That's negative 2 squared plus negative 4 squared. So 4 plus 16, which is the square root of 20. So I know the distance from xy is the square root of 20. So I'm going to erase this so I can figure out my next one. Oops. That's the next problem. Okay, so my next one, let's do zy. So zy. So my points this time are negative 2, 0, and 2, negative 2. So x1, y1, x2, y2. So the square root of x2 minus x1 plus y2 minus y1. Those are squared. So I have 4 squared plus negative 2 squared. So 16 plus 4. So I now have, this is now the square root of 20, so I now have at least an isosceles triangle because I have the square root of 20 twice. And isosceles triangles have two congruent sides, so I at least know the possibility could be isosceles. So now I just got to check that last side. So xz, so x is 4, 2, and z is negative 2, 0. So I'm going to do this super quick so that we can just see what we get. Just make sure you copy this all down so that you can try to do it yourself. I just don't want to take up a ton of time, but I say attempt it yourself to see that you're doing it the correct way. So when I simplify it all out, I get the square root of 40, so we only have two congruent sides, so it is an isosceles triangle. So now I'm going to erase all this so that we can see our next one and start trying that one. So first I need to find my points. X is going to be 0, 3. Y is going to be 4, negative 2. And Z is going to be negative 3, negative 1. So I got to find the distance. So let's take the distance of XZ first. So my point X is 0, 3. And Z is negative 3, negative 1. So I have X1, Y1, X2, Y2. So we do our distance formula because we're trying to see if it's scalene, isosceles, or equilateral again. So I'm going to write this out to see what we get for this. So I suggest trying it on your own to see if you're doing it the correct way. So when I simplify it all out, I get the square root of 25, which is 5. So now I need to check another side. So let's go ahead and try xy. So I'm going to erase all this, put up my 2 points, and then I'm going to try the distance formula. So here are the 2 points I'm going to use, and I'm going to plug them into my distance formula again with x1, y1, x2, y2. And that is the square root of 41. Now we got to check our last side to see what our last side is going to be. So we need to check zy, so I'm going to put the points up and show you that first. So here are the 2 points I'm using. I'm going to plug them into my formula again with the x2 minus x1 squared plus y2 minus y1 squared. So I'm going to get 4 plus 3 is 7 squared plus, this becomes a plus, so negative 1 squared. So 49 plus 1, so square root of 50, and we have none of them are the same, so this is a scalene triangle with no sides being the same length. Okay, what is the most precise classification of the quadrilateral formed by connecting in order the midpoints of each figure? So to be able to do this, you're looking at the word here, midpoints. So it is the point that sits in the middle of all of my side lengths. So first I'm going to find all of my points, A, B, C, and D, and I'm going to label them. So just give me 1 second while I do that. So here are my points, A being 0, 3, B being 3, 0, C is 0, negative 2, and D is negative 3, 1. So to find our midpoints, this is from semester 1, we have to add the x's together, divide by 2, add the y's together, divide by 2. So if I'm trying to find the midpoint of this AB, I'm going to take this x plus this x, so 0 plus 3, divided by 2, and this y and this y, add them together, divide by 2. So that midpoint is going to be 3 over 2, 3 over 2, which is technically 1.5, 1.5. So I would go over 1.5 and up 1.5. So if I go over 1.5, up 1.5, my midpoint's going to sit right about there. So now I need to find my next one. So let's say we're looking at BC this time. So this line. So I'm going to erase kind of some of this part so that I can write. So my next one, I'm going to add my x's, so 3 plus 0 divided by 2. And my y's, so 0 plus negative 2 divided by 2. So 3 plus 0, I got 3 over 2 again. And 0 plus negative 2 is negative 2 over 2. So I got 1.5 and negative 1. So if I go to the right 1.5 and down negative 1, we're sitting right about there for that midpoint. So my next one I'm going to do is CD. So this one right here. So I'm going to erase part of this so that I can write. So I'm going to add my x's, so 0 plus negative 3 divided by 2, and my y's, negative 2 plus 1 divided by 2. So I got negative 3 over 2. Negative 2 plus 1 is negative 1 over 2, so negative 1.5, negative 0.5. So I'm going to go left 1.5 and down 0.5, so that's going to sit right about there. And then I have to do my last one. So my last one is between A and D, so I need to check AD here. So I'm going to add my x's, so 0 plus negative 3 divided by 2, and my y's, 3 plus 1 divided by 2. So I'll have negative 3 over 2 and 4 over 2, which simplify to negative 1.5 and 2. So I'd go to the left 1.5, and then I would go up 2, so it would sit right about here. And then we would need to connect all our points, like so. So you can see that the classification of this quadrilateral is going to be a square. Okay, oop. Okay, the classification of its midpoints, it looks like a square. So you can see that inner picture that we created by connecting all our midpoints is a square. So now we're going to try this next one that's right here. So give me a second while I erase all this. Okay, so again, you would find your B, E, D, and C, or C, B, E, D, okay? You would find your midpoints, you take the average. So you add the x's, divide by 2, add the y's, divide by 2. I'm going to guesstimate so that we can get through this a little bit quicker. But on homework and tests, if you don't show your work, I'm not going to give you credit for it. So BE, it looks like it sits about here. OE, CB is going to be right about there. CD is going to be about here, so let's connect them. And you can see that this also makes a square, okay? You could use the distance formula to check your answer to make sure it's not a parallelogram or something of that sort, but you can see that it does make a square. So my next one, my midpoint is going to sit right about here, there, there, and there. Whoop. And I would connect them. Okay, this one does not look like they have all the same lengths. And you can tell that it is a rectangle. So you could check the distance formula using those points. These two sides should be the same, and these top and bottom sides should also be the same. So now let's check our last one. So I'm going to go ahead and draw the picture. And you can tell that they don't have 90-degree angles, and they all have congruent sides. You would use the distance formula to find the sides, and you can tell that it is a rhombus.